Alright, so we're going to talk about rational functions that do have slant asymptotes this time. So these are going to be a little bit more complicated than the last video I did with the just horizontal and vertical asymptotes. So we kind of have a checklist of different things we want to find, and then we're going to find a rough graph of it as well. So jump right into it. The first thing on my list are x-intercepts. To find that, what I want to do is factor the numerator of my rational function. So I can just common term factor here, pull out an x squared, and that would leave me with x plus 1. That would be a factored version of the numerator. And to get my specific x-intercepts, I would want to ask myself, what values plug in for x that make each of these separate factors 0? So to make this 0, just 0, so one of them is going to be at 0. We'll go ahead and put that on our graph as well. So we're going to have an x-intercept right there, and then a negative 1 makes this whole factor 0, so we're going to have another one at negative 1, so that's going to be one spot over there. So right now our purple dots are x-intercepts. The y-intercept is probably easier to me. It's basically, what do we get left over if we plug in a 0 for each x in the original problem? So if this is 0 and this is 0, it's going to be 0 over negative 4. 0 over any other number is just going to be 0. So I'll leave it purple. Normally I would change color, but the reason is, if this is at 0 as well, they're actually going to share that dot. So I don't want to color over a dot we've already made. So our y-intercept and our x-intercept are actually the same point on all of those. Horizontal asymptote. Normally we would check this for what degree is the biggest on the top, on the bottom. They'd have to be the same. We divide a bunch of stuff out. But here we realize right off the bat that the degree of the top is a 3 and the degree of the bottom is 2. So it's not going to work out for us. We're actually not going to have one here. Vertical asymptote. So basically, how far, even though it's vertical asymptote, how far left or right our pieces of our graph move. We need to factor the denominator. So here, normally when we have examples, we think product sum. Here we actually don't have 3 terms, so we're going to have to do something different. We can't common term, but we can do difference of squares. So this can be written as x squared minus 2 squared, something squared minus something else squared. So our 2 factors, if you think back to whenever you talked about factoring, you probably had a plus b and a minus b. We get something similar there. Just like what we asked ourselves up here, it's what values make each of these 0, so it's going to be negative 2 and positive 2. Let's go with green for those. So we're going to have x equals negative 2, x equals positive 2, and we'll actually have, rarely do we see this, but we actually have 2 vertical asymptotes here. So I'll do the one on the right first. That's at 2, and then one at, oops, that's negative 1, one at negative 2 as well. So we're going to get something kind of funky in the middle, but on the outside it's going to follow kind of our normal situation. The last thing that's kind of the main focus of this video is slant asymptotes. So basically, instead of perfectly flat, perfectly up and down, it's going to be at an angle. To get that, we need to divide the original function. So here we're going to have to do long division. And I'm going to put in as many placeholder values as I can. That makes everything easier for me. If I can, I always go synthetic division, but not the case here. We're going to get 0x and plus 0. Okay, so long division, I'll go through this one quickly. What times x squared gives you x cubed? Just an x. So we have to multiply through all of those. We're going to have a 0x squared. and then a minus 4x. We need to subtract going down, so that cancels. X squared minus 0 is still x squared. 0 minus a negative is going to turn into addition. We're going to drop down technically to 0. Same thing, we're going to ask ourselves, what times x squared gives me x squared? Well, that's just 1. So we're going to get, technically for slant asymptotes, we could stop here, and I'll talk about that in a second, but we'll get that. We'll still get 0x, and we'll get negative 4. Again, we subtract, so it cancels. We get 4x, 0 plus 4 when you subtract a negative, and that's the remainder. For slant asymptotes, all we care about is this part, and that's actually going to give us the equation of a line that represents that slant asymptote. If you want a slope in there, it's just going to be a 1. So now we just need to put all this on the graph. Let's go ahead and put the slant asymptote up in blue. So we're going to start up 1. We're going to go up 1 over 1, up 1 over 1. Same thing in the other direction. Make something that looks kind of like that. From here, this is where you would either make a table or plug in values to see kind of what happens at these asymptotes. So I want to see, for example, vertical asymptote of negative 2. I want to see if I get something that shoots up towards infinity or towards negative infinity, so I know if it's in this kind of shape or something kind of snug down there. So if this is negative 2, maybe I would plug negative 2.1 into that. So I'll go ahead and do that kind of quickly. Negative 2.1 cubed plus negative 2.1 squared divided by, and then I got to do that bottom kind of piece too. Since it's since there's so many different exponents and stuff, you just have to keep your parentheses in line. That should get you in the right direction. But when I did that, I got a negative number. So what that tells me is my whole kind of graph is going to be somewhere in this region. I would want to plug something in on the other side. So let me do that as well. That'll kind of tell me what's going on in the middle. So let's go with negative 1.99, something like that, something really close. Negative 1.9 cubed plus negative 1.9 squared. All that divided by negative 1.9 squared minus 1. Okay. So that gives me something pretty close to 0. So I would actually want to go in and get even more specific. So if I change this to 0.99, maybe that'll give me a closer picture. 0.99. Ooh, and if I do that, I get really close to 0 as well. So what I'm going to see is that I'm having something that when I get really close to here is kind of hugging this. So we might have some weird curve in the middle. And then let's test something on the other side too, just to get that last little piece. So I'm going to test like 2.01 or something even closer if you can. 0, 0, 1. Okay, just because I have that many spaces already typed out in my calculator. 2.001, just got to be really close. So it looks like we're gonna get something that's up here. So we'll have that kind of shape. And then we'll have to kind of go back in and mess around with the middle. So that's it for slant asymptotes.